Hello, and welcome to our discussion on the way tech is transforming health and medicine. We're slap bang in the middle of the fourth industrial revolution. Every day, new technologies such as artificial intelligence promise to change the way we live and work. And one of the sectors in which these emerging technologies are having the most profound effect is medicine. Tech is changing the way we diagnose, the way we treat. It's enhancing our entire understanding of human biology. We're talking in the week the AI network developed by DeepMind has revealed its ability to predict protein structures from their amino acid sequence, a breakthrough that can accelerate the way we understand the building blocks of cells and enable quicker drug discovery. In the words of a biologist at the Max Planck Institute, this will change medicine, it will change research, it will change bioengineering, it will change everything. Medicine's becoming personalized, data-driven, more efficient. But can artificial intelligence really replicate the human touch? Are we going too far, too fast? How do we mitigate risks and regulate this new world? I'm Kim Fletcher, and I'm joined by two doctors to talk about that. They're not actually medical doctors. Rather, they are PhDs whose work puts them at the heart of this revolution. Let me introduce them. Dr. Ali Parsa is the founder and CEO of Babylon, the revolutionary AI and digital health company. How's this for ambition from the company's website? Babylon's mission is to put an accessible and affordable health service in the hands of every person on Earth. We'll hear shortly how he's achieving that. Ali clearly likes traveling fast. He was featured in the Maserati 100, a list that recognizes game-changing entrepreneurs. His PhD, by the way, is in engineering physics. And Dr. Mike Lynch is a technology entrepreneur and the founder of the tech investor Invoke Capital. Mike's the nearest thing we've had in Britain to Bill Gates. He's the founder of Autonomy, one of our most successful tech companies, and the winner of far too many awards to list. Back in 2008, he was named by an admiring business magazine as one of the top 5 most influential people in technology. The other 4, Tim Berners-Lee, Steve Jobs, Jimmy Wales, and Eric Schmidt. Mike was elected to the Prime Minister's Council for Science and Technology in 2011. He's a fellow of the Royal Academy of Engineering and an honorary fellow of Christ's College, Cambridge. Mike's PhD, signal processing, followed by a research fellowship in adaptive pattern recognition. Let's start with you, Ali, because I'd like to get a grip on this for those of us who don't have your tech ability. Tell us about Babylon, what Babylon is doing, and how you're marrying medicine and tech.
Thanks, Kim. You described Babylon's mission to make healthcare accessible, affordable, put it in the hands of every human being on earth. And if you dissect that statement, to make healthcare accessible nowadays is a lot easier, but we do need to use technology. So what we do is try to make most of the healthcare most people need available on the devices most of them already have. One of the proudest moments in the history of Babylon was when His Excellency President Kagame gave digital first primary care universally available for free to his entire country by giving them Babylon. The problem is there is no accessibility without affordability. And if you look at the costs in healthcare, they sit in 2 fundamental buckets. On one hand, it's salaries. 2/3 of all the money we spend globally goes into doctors, nurses, healthcare professionals that in each country are among the rarest and yet deservedly the most expensive asset that country has. On the other, if you cut it by diseases, 70% of all our costs are in predictable, preventable diseases. So to cut the costs of healthcare substantially, what you have to do on one hand is to automate as much as possible that what human beings do in order to be able to give them operational leverage. And on the other hand, you need to collect as much data and signal from our bodies as possible in order to be able to predict and therefore be able to prevent diseases. That is fundamentally what we do. And the core of our capability, therefore, is the technology that you and I are going to go ahead and speak about with Mike.
That's absolutely fascinating because there are those 2 things you raised there. It's the accessibility, but it's also the ability to pick up information. Mike, picking up information, that's something that you have done all your working life, or I think most of your student life, and recognizing information. Tell us, this is a hard question, but can you give us a framework to work with here in terms of the role of tech? How big is it? The stuff we see, and presumably there's a huge amount we don't see.
So obviously you can have operational things, you know, we might think about things like automating, getting appointments booked, electronic patient records, that sort of thing. Fairly obvious, and the interesting thing there is in some ways healthcare has been a little bit slower than you might expect to adopt some of those things. Then you have another big category, which is tasks which traditionally could only be done by a human, where recent advances in things like artificial intelligence are now showing performance which is on a par with a human. So, for example, looking at scans and interpreting them in certain cases recently, results from technology there are on par with the practical results that you get with a human. And obviously that means that you have the ability to process and look at very much larger numbers of scans. Then we have some of the much more difficult and controversial areas. So for example, diagnosis, you know, a few years ago, there was a statistic that 11% of NHS diagnoses were actually wrong. So we start from a point where actually, you know, even doctors make mistakes. And every time we make a mistake, not only can it lead to much more costly and longer treatment, but obviously we can have much more adverse medical outcomes. So the question is, can you support that process and make that accuracy better? But the most interesting opportunities are really coming from two things. We have a very large amount of data that we didn't have in the past. And we now have the ability to go in and analyze that. So for example, some things that might seem rather prosaic, but actually cost a fortune, accidents in hospital, someone slipping over and the treatment and outcomes that are caused by that. Well, having large amounts of data can allow us to look at the causes of such things and optimize them so that reduce those. But perhaps the most interesting one is the move towards personalized medicine. Up to now, medicine has generally worked on a more cohort type basis, an idea that treatment for a disease is something which would be applied across most of the population. However, that's not what humans are like. We have very specific differences in our genetic makeup and our phenotypes, and that leads to interactions that are very different with diseases, but also interactions that can be very different with drugs. So one of the things that we're seeing is some incredible advances, for example, in the management of cancer from a clinical point of view, by actually personalizing and truly understanding that, for example, lung cancer is not one disease, it's upwards of 10,000 variants. If you can imagine a world where we're going to be that personalized and things are going to be that specific, then you can see that we really have no other choice other than to embrace data-driven technologies.
Thank you. And I knew we could rely on you to give us some buckets that we could actually compartmentalize in that way. I'd like to get on to the really technical stuff a little later. First, just looking at the immediate applications. Ali, I was going to say we've come through. We haven't come through. We're in a stage of the COVID crisis. How has that played out for Babylon? And what's been the responsibility, what's been the help given by tech in that?
So you're absolutely right that we will come through this pandemic as we have come through every other pandemic in human history where we had significantly less capabilities than we have today. So but the cost of this pandemic has been huge, not just economically, but also in life. I lost my own father to this pandemic. Yesterday, United States lost more people on a single day to the pandemic than it lost in 9/11. So we've paid a huge cost for this pandemic, and I hope we come out of it learning the single most important lesson the pandemic taught us, which is, by the way, the foundation of how we created Babylon. The foundational insight behind Babylon was that we spend all of our time in healthcare fixing broken people. We wait until things go wrong, and then we will spend money in sick care. That's what you and I used to do 20 years ago with our cars. We will drive it until it breaks down, then we fix it. Nowadays, nobody does that because we buried enough sensors in our cars and we service them regularly. So therefore, cars practically never break down. And they are much cheaper to maintain as a result. What we need to do with human body and what this pandemic showed us is we could not afford to wait for people to get sick. So we started taking draconian measures in order to keep them away from getting infected or ill because our systems couldn't cope. The problem, of course, Kim, is that that is not the only problem that we have been facing. In our country, we've been having crises of mental health, diabetes, chronic conditions have been running havoc across all our health systems, and yet we got used to them. We allow them to happen. We are perfectly okay as a human society to lose 1 million people a year to suicide, most of whom, if their cry for help was heard earlier and something was done about it, their lives could have been saved. So I think the lesson that we need to take away from this pandemic is a fundamental change in the way we do healthcare, which is instead of waiting for crises and emergencies to happen and do sick care, we need to now turn the case around and be able to try and monitor people, to try and keep them healthy. And technology, not just simple technology like sensors, but AI, because all that data that we collect with people are useless unless we can put some insight behind it, is critical in being able to deliver that. We've done it in Babylon during the pandemic period, and while we saw a 13-fold increase in our revenue, we almost saw 0 increase in our number of employees, because we just leveraged operationally our technology to be able to use the same number of doctors to deal with significantly more patients.
Do you recognize that picture, Mike? Have you been sitting through this crisis thinking, right, we need to resolve, here's a cleverer way to do this? I wonder if we've done enough. Have you seen opportunities where tech could play a further role?
Well, I think one has to separate a normal situation from a true out-of-the-blue crisis. I would completely agree with everything that Ali has to say about, prevention of long-term medical conditions, things like the diabetes epidemic, etc. But I think it's unwise to fold that into thinking about the epidemic, although this particular coronavirus does tend to do better in cases where there's an underlying morbidity. You only have to look back at various flu epidemics in the past where actually the most likely people to die were some of the healthiest. So it's a separate situation. It's actually been a fascinating game of two halves in that we saw this incredible scientific effort with the vaccine, and we now have a completely new approach, an mRNA vaccine. And that method, the mRNA method, is going to affect, I suspect, cancer and a whole series of other things after this. And ironically, the fact that mRNA has gone through the regulatory process so quickly because of this crisis is probably a good thing for other diseases follow. But I think we've also seen a real failure. When you look at the organizational issues around test and trace, logistics, the app, the way in which the problems on an international scale have been dealt with, the ability of the political system to respond and manage the situation. One would have hoped that by comparison of our forefathers, given that we have this magical technologies, even just at the basis of a computer be able to manage logistics, we would not have got ourselves into quite the mess we have. And I think there's going to be a very interesting question for us as a society as to what got in the way. In the past, we had people having to ride around on horseback to sort out things, and we had no ability to tabulate. Now we've got incredible communications, we've got incredible machines, and yet we've hit a different problem. And it's to do with the fact that we haven't resolved some pretty fundamental issues when it comes to things like healthcare. We get ourselves in a real mess over privacy, for example. And that, I think, has been something that, because we didn't have a framework that was accepted and sorted out, just as it's held back the use of technology in health service, I think it held back our response to the pandemic. So perhaps it's time to sort out some of these problems that have been lying there where tech meets healthcare?
Well, I think two really interesting questions from that. The first, do doctors like guys like you, or are they suspicious of guys like you? Ali, you go first, Ali. Did they tell me what the medical, when you arrived, did the medical profession look at you and think, what are you doing? Or did they embrace you and welcome you in?
Doctors are like every other group in society. We are now NHS's, for instance, largest primary care practice. We built it over 2 years, a larger practice that it took people a lifetime to build. And we're the largest employer of GPs, I understand, in the country, for a single company to employ them, that is. So all of these people love working with us. They show 3 times more satisfaction than the average BMA survey does with their job. We have a huge amount of support among groups of doctors on different medias. And yet we have a group of doctors who absolutely dislike what we do, and they dislike it on a variety of different reasons, right? And that's okay, because you will see exactly the same distribution of adoption of technology in any other trend in society. Doctors get a bad, if you want, a bad reputation for being anti-technology or antiquated. In my experience, doctors are no different than any other group. It's just that their voice get heard probably a little bit louder. So those who are anti get a bigger platform sometimes, as do those who are pro something. And we see it, by the way, in this pandemic debate. For every person who says that we should do A as a response, there is another person who says we should do B, and then an equally strong women group that says we should do C. So I think doctors' distribution of adoption of technology among doctors is the same as any other group in the society.
Interesting. And let's look at that privacy argument, Mike, which you raised. You know, in the old days, we were always brought up on that cliche, I'm a doctor, trust me. We're scared now, aren't we? Because it's I'm big tech, trust me. And we're a bit more worried about that somehow, because it seems impersonal. You're no longer having to dig up our bodies to investigate how the human body works. You've got access to a huge amount of our data, and you can kind of look inside us. And what's more, it becomes a commercial property. Isn't that behind the privacy issue?
Well, I think there's a series of aspects, and I'd actually slightly disagree with Ali, having spent the last 20 years bringing advanced tech into the professions. The two that are most resistant are the doctors and the lawyers, which is, I think, quite interesting. Now, it's a very nuanced point in that if you give a doctor a better, monitoring system, heart and vital signs monitor, they'll obviously grab it. But there's a slight sort of distrust, I think, of things that are seen as somehow could be interpreted as replacing some cognitive aspect of the doctor. And it's the same with the lawyers. And the only thing I can think is that they're both professions that in reality have to guess from time to time. A doctor doesn't necessarily know the answer. They have to make, their best guess. And there seems to be in professions like that a little bit of concern when something's coming into that process. And that's why, for example, we do see diagnosis support tools not getting the take up that you would have expected them to have had by now in the technology cycle. So I think you've got a definite effect there. That is going to change. I think you have a younger generation who are more comfortable with technology, and then you have no choice. The more that personalized medicine comes in, then the more that this is all going to happen. And so it's a change. It's just slower than you might have expected. Coming back to your other part of your question about big tech, I think there are a series, again, of slightly different fears from the general public. You have probably a slightly overblown fear about the idea that somehow everyone's going to find out that I've got a dodgy ankle or whatever. And this is very much what you will see in the newspapers whenever anyone tries to use data in general. That, I think, is something where the debate has failed because the advantages of doing some of these things have not really been well explained to the general public. So they see the fear, they see the disadvantage, but not the advantage. And of course, ironically, having an electronic healthcare record well encrypted in a good computer system is far more secure than having it in the good old days of paper in the surgery with the receptionist's intern daughter seeing it. So different situation. The big tech one is interesting. There is a distrust of big tech. I think it's very well founded. People do understand now that as they use these systems, information is put together, and because of the more powerful technologies that are out there, it can all be fused together. And the question is, what is that information used for? Who owns it? And how can it be misused? And you even have national boundary issues here. So, for example, do I really want my healthcare records going off to a server in the US where they have the US Patriot Act, and those can be immediately looked at without going through a court process? So there is a well-founded fear of big tech, and I think it's one of the things where, whether it's valid or not, it would be very unwise not to go very sensitively with the general public. It's better to win a series of small battles than overreach. So, for example, Google's project with the Royal Free that kind of rebounded a bit because it wasn't well enough explained, and then suddenly there was a reaction to it. It's probably an example of how not to do it. So it is something that is difficult. There are actually some really difficult technical problems at the center of it. So, for example, it may seem a very good idea to take a large amount of NHS data and then use it to look at, for example, the efficiency of treatments. And the first thing that someone technical will say to you is, well, you can anonymize that data. And of course you can, but actually the AI technologies are now so powerful that for a relatively rare disease, you could also de-anonymize the data. And the day that happens and that gets run in a newspaper, we all go backwards 5 years. So it is something we need to be really careful about, how we bring the general public on this journey, even if there are undoubted great benefits to going on it.
That's absolutely fascinating. I came on expecting to be reassured, and you were going to tell me I was a Luddite and I was better off being healthy and not to worry about anything. But now I'm going to start fretting all over again. Is it something that we are going to regulate successfully in this country, do you feel? Does it require, is it just a regulatory matter and it can be sorted with goodwill?
Yes, I think it needs some very forward and brave regulation. I think, in a sense, it is a classic government role where they need to take a position about, for example, who owns your own medical data? What can it be used for with bulk consent, and what must be used for with specific consent? And I think if we had that framework in place, which will require some brave political act, because no matter what you do, it will be criticized, then we move forward and we can start to get the benefits. And I think one of the things that the technology world needs to do is make sure that we are communicating the incredible benefits of taking these steps forward, which do in reality far outweigh the risks. But to ignore the risks and just tell the general public that they're being a bit silly about this isn't going to work. So more forward-looking regulation. And of course, one of the great advantages post-Brexit is that we're no longer tied into a European regulatory framework, which means that not only can we solve problems like this and lead the way in things like data and the issues around ethics and management and ownership of data, but we can do things like make our regulatory framework adapt to this massive move to personalized medicine. At the moment, the regulatory framework has been generally put together to be all about cohorts. And that model just doesn't work in a personalized medical world where, your drug may actually be relevant to a very small number of people. How do you test that? How do you clear it? How do you monitor it? And so there is a great opportunity to move into the next generation and really see the power of these technologies and things like, what Babylon's doing.
And talking of what Babylon is doing and this idea of independence and an ability to make our own course, you've chosen to be in Britain as Babylon, even though you're an international business. Why is that? Is there something about British tech? Is it just a good place to do business? Or is there a different reason, Ali?
Um, can I answer that? Can I first follow up from what Mike was saying and then come back
Yeah.
to that? Is that okay? I think Mike very well described all the benefits of technology and all its challenges. I think that the problem, the issue is becoming more complex very fast. And that is because while we have seen huge improvements in technology, and we are just about to see a massive leapfrog if quantum computing comes, if 5G gets well distributed, if the Internet of Everything and sensors go everywhere, if prescriptive analytics come, augmented and virtual reality comes. So all these things that we have today, if they get well distributed, we're going to see a massive leap, even in what you and I are experiencing today. But I think the picture is going to become far more exciting because, and Mike alluded to that, because we're just about to start seeing a massive biological revolution too. I think the advances in biology and in synthetic biology are mind-boggling to me. I mean, if you look at, we just saw what biological interference intervention is done with this vaccine, but immune therapy is doing in cancer. This is the easiest stuff. We're now seeing that people are starting to be able to read brain waves and get monkeys to move robots in the next in another continent. We're seeing that synthetic biology is starting to mix the gene of a bird with a mouse and get it to sing, a gene of a jellyfish with a fish to get it in different brilliant colors. A rat has been created that is 6 times smarter, a worm that can live 10 times longer, a tomato which does not age. I mean, it's just beyond our wildest expectations, if you wish, the kind of things that biology can bring in. And some of these biological improvements now is because of the technological improvement that we have. So to your point, the work that DeepMind just produced on protein on protein mapping, if you wish, will have significant new effects on biological. So I just wanted to say that this is no longer a technological thing. It's now a technological and biological revolution we are having, and the combination of two that will create significant complexities for our regulators to try and manage. Coming back to your question on Britain, look, I came to Britain as a refugee. This country, I was 16 years old. I was on my own. I'm one of these guys that you see on TV trying to walk their way into the country. This country has been incredibly good to me, and I am amazed. It's been welcoming, hospitable. I am forever grateful to it. And it's and in the same way that it's been welcoming to me, it's been welcoming to many other people from many other countries. And London, for instance, but not just London, many other hubs in our country have become a place of gathering of intellect from all over the world. And advancements happen when different people come together with different ideas and have the freedom to express it. And that's what makes London such a special place. The same is true in Silicon Valley. The same is true in other parts of the world. I'm not just saying we're unique, but we have nothing to be shameful about. So we've done a phenomenal job in creating a multicultural society that values people's ideas. And as long as that persists, I'm a huge believer that Britain will continue to be a global leader in innovation.
And last word with you, Mike. Britain still a tech leader?
Oh yes, I think the fundamental science base in Britain is phenomenal, and a lot of the things that we've been talking about today actually came out of research in the UK. So I think we're in a great position. I think the opportunity for us now that we are able to plot our own destiny a little bit more is to really show some of these technologies in place. It's a very exciting future, and some of the things that Ali's talked about, but there's also real here and now clinical need. We have, as most countries in the world do, we have a complete disaster in the interface between healthcare and social care. You know, you have an elderly person who is getting starting to show signs of dementia or Alzheimer's. At the moment, the way that situation is resolved is that for some, they'll have a particularly bad episode, usually caused by something like a urinary tract infection. And then they move from social care into a hospital where they sit there, and then there's no way of getting them out of that situation. And they become, from there, into a care home. The hospital bed is blocked. A simple application of technology using the ability to monitor what they're weeing into the loo to work out whether they have a urinary tract infection would mean that you could then treat that urinary tract infection at home, and their cognitive level goes back to the level that they're actually able to function at home. And that buys you, perhaps 6 months to 12 months of that person living at home. That is a massive effect on a here and now problem. And what we need to do is really use our new freedom in the UK and our amazing science base and some of the companies like the ones we're talking about today, and show some of these things actually revolutionizing healthcare today. And that will build a great business and a great opportunity and a great health service for us, for people, as these amazing discoveries that are coming down the pipeline actually become clinically relevant over time. So it is a time of great opportunity.
Well, on that note, thank you very much indeed, gentlemen. That's a fascinating glimpse into what's happening now in medicine through tech, but also what can happen in the future. Thank you.